Hello everybody. We are moving on from linear equations and taking a break for a bit, and we're going to talk about exponents for the next couple weeks. And the first thing we're going to do is talk about multiplication properties of exponents. So the objectives of this video are that you will be able to multiply powers, I'll show you what I mean by that, and combine like terms. So we already learned this, but it's important to remember the difference between this and this, and you'll see that in the video. Alright, we're going to start by combining like terms. So a like term or like terms are terms, this is a term, this is a term, that have the same variable, and that variable needs to have the same exponent. Now this exponent is x to the first power, and so is this. So they're the same. And what I've said before about combined like terms, it helps if you say it aloud, because it's like reading poetry. There's a cadence to it, and it makes sense if you say it. 7x plus 8x is 15x. Let's try that again. 20w minus invisible 1w, so 20w minus 1w is 19w. 11k to the fourth plus 7k to the fourth would be 18k to the fourth. Notice that this k to the fourth stayed k to the fourth. When you add, this is important, when you add or subtract, the variables stay. They just stay. K to the fourth, w, x, they don't change. The coefficient changes. Now, remember how those all made sense? Let's listen to this one. 1x to the fourth minus 1x to the third. X to the fourth minus x to the third. That doesn't have a flow to it. So this one is already simplified. You could also just say, if that happens, just say x to the fourth minus x to the third. Just write the problem again, and that's it. You can't do anything else with it. Here we have a big question, so immediately I look for like terms. So I have a 4ab with no exponents, or they're ones. So I'm going to look and find another ab. So let's see, ab here, nope, a squared 5, oh, right there. So what I do first is circle like terms. So 4ab, notice this, I'm going to include that minus sign with this 1ab. Okay, so that's really a negative 1ab. That minus sign belongs to the ab. It does not belong to the 5. So I'm going to write these together. So I took this 2a squared b, and I combined it with the positive 2a squared b, so this is a negative 1 and a positive. And then I took this ab squared. There are no other ab squareds, so that's going to have no partner, but there is a 5 and there is a 4, and those are called constants. So now I'm going to combine these. So 4ab minus 1ab is 3ab, then plus negative 2a squared b plus positive 2a squared b is 0. So I don't need to even include it. I'm not going to write it. But I will take this and put it down here, ab squared, because it has nothing to combine with. And then I'll take plus 5 and plus 4 and combine that to 9. So now this is simplified. All my like terms are placed together. This is a quick little activity that will help show you how to multiply powers. So, the shortcut way. So 2 to the first multiplied to 2 to the first means 2 multiplied to 2. So that means 2 to the second power, because we have two 2's. I want you to complete this table with me. This is 2 to the second power multiplied to 2 to the second power. So I need 2 2's here, and then I'm going to need 2 2's here. And how many total 2's do I have? 1, 2, 3, 4. I have 4 total 2's. Here I need 2 to the third, so I need 1, 2, 3 2's multiplied to 1 2. So let's count. 1, 2, 3, 4. So I have 2 to the 4th power also. We'll talk about that in a second. 2 to the 4th power, so 1, 2, 3, 4, 4 2's. 2 to the 2nd power, 2 2's. Now I'm going to count up all my 2's because they're just multiplying. So 1, 2, 3, 4, 5, 6. 2 to the 6th power. Alright, lastly, 2 to the 3rd power. So 2, 2, 2 multiplied to 2 to the 3rd power again. 2, 2, 2. How many total 2's did I write? 6. That's also 6. So let's do the question. What is true for 2 to the 2nd power and 2 to the 3rd power multiplied to 2 to the 1st power? Well, they're the same. They both equal 2 to the 4th. And it says, what relationship do you see between the sum of the exponents of 2 in the first column and the exponent of 2 in the third? So example, watch this. What's 2 plus 2? 4. What's 3 plus 1? 4. What's 4 plus 2? 6. What's 3 plus 3? 6. You write 3 2's here and 3 2's here. That's a total of 6 2's. This is going to be the shortcut we're going to use. And the shortcut says this. If you have a multiplied to a, but the exponents are different, or even if they're the same, but they have exponents, you can add the exponents. Alright? And I'm going to prove it to you. A to the 2nd power multiplied to a to the 4th power equals a to the 6th power. This is called multiplying powers because this entire thing's called a power, and this is a power. So, how many a's does this denote? This says that I have 2 a's, so I have 2 of them. This says that I have 4 of them, 1, 2, 3, 4. Well, how many total a's do I have? 1, 2, 3, 4, 5, 6. So, this equals a to the 6th power. What I could have done is just gone like this. What's 4 plus 2? 4 plus 2 is 6. That's what we're doing. That's the shortcut. So, real quick, one more. X to the 3rd multiplied to x to the 10th. What do you think that is? How many 3's, or how many x's here, how many here? Add them together. It's going to be, sorry about that, x to the 13th. All you have to do are add the exponents because you have 3 x's plus 10 x's. So it's x to the 13th. Alright, here's a page where we can practice. We have 11 to the 4th power. Remember what it means. And I might, on a couple of worksheets, make you write this out. It means you have 4 11's multiplied to 3 11's. So that's a total of 7 11's. Okay? Here are 2 5's multiplied to 2 5's. So it's a total of 5 to the 4th power. They want us to rewrite the expression using a base only once. So here's one base and the exponent. So what would this be? 4 p's multiplied to 3 more p's would be a total of 7 p's that are multiplying. Now on this one, you can only do it if the base is the same. So I have 3 y's here. So you could say 3 y's here and pair that up with 6 y's here, and then with commutative property move the z2 over. So how many y's do I have? I have 3 y's plus 6 more y's. So that's going to be y to the 9th power, 3 plus 6. But then I'll just say z squared next to it because it is multiplying. So there's my answer for that one. Here's a little advice we already kind of talked about. When variable factors have more than one base, be careful to combine only those powers with the same base. This is where you're going to hear me say things are not glued together. Okay, ready? These are not glued together. These are not glued together. Here's what I mean. 2n to the 5th multiplied to 3n to the 4th. Here's what you have to do. 2 times n to the 5th. That's what's really happening here. multiplied to 3 times multiplied n to the fourth. Now I'm going to put this 2 with the 3. I'm going to say, do commutative property of multiplication. 2 multiplied to 3 multiplied to n to the fifth multiplied to n to the fourth. So what is 2 multiplied to 3? What's 2 times 3? 6. Now I have 5 n's multiplied to 4 n's, so that's a total of 9 n's. So look what I did. I multiplied the 2 to the 3 to get 6, and then I counted up all my n's. 5 n's and 4 n's are 9 n's. That's what I did. I want you on this worksheet to put them together, and then you'll get them right. Put the 2 and the 3 together, and then put the n's together. Let's try that again. So I'm going to rewrite this one. Notice that it's really -4 multiplied to x to the third power, multiplied to 2, which is multiplied to x. They're not glued together. These are not glued together, and that's, you have to remember that. So now I'm going to pair up the coefficients. Okay, so now all I have to do is -4 multiplied to 2 is -8, and now I'm going to count up my x's. 3 x's, and that's an invisible 1x. So x to the third power multiplied to x to the first power gives me x to the fourth power. That's my answer. Okay, let's talk about parentheses. Parentheses, as long as there is not an exponent right here, see right here? There's not one. Ignore parentheses. Because of the associative property, I can drop this parentheses and rewrite it. Watch how I'm going to rewrite this. What I did was I just wrote 7 multiplied to x, because it is, multiplied to 3 multiplied to another x. That parentheses is not needed one bit, so get rid of it and don't let it throw you off. So let's put these numbers together. 7 multiplied to 3 is 21, and I have 1x multiplied to another x, so that's a total of 2 x's. 21x squared is my answer. Okay, here we have d multiplied to d to the fourth multiplied to d to the third. There's an invisible 1 here. I don't need those parentheses. So I have 1 d to the first multiplied to d to the fourth multiplied to d to the third. And remember what that means. It means if you write this out, you have 1d, then you have 4 d's, and then you have 3 more d's. That's a total of 8 d's. So this is d to the 8th, because 1 plus 4 plus 3 equals 8. So the answer to this is d to the 8th power. Okay, let's do this one. Let's combine all our m's together. So I have m squared multiplied to m3 multiplied to m1. So 2m's, 3m's, and 1m adds up to 6m's. So it's m to the 6th power multiplied to 7. Now, most of the time I want that number, that coefficient in front. So we say 7m to the 6th. Let's do one more here. Okay, they're not glued together. These are not glued together, so I use the commutative property to move them all around. So I have 2 multiplied to 7, which is 14, multiplied to 2, which is 28. So once again, 2 times 7, 14, multiplied to 2 again is 28. I'm going to put my y's together. I have y to the third multiplied to y to the fourth. That gives me y to the 7th. There's 7 y's here. 3 here and 4 here. And lastly, I have x to the 2nd power. It does not have any other partner. There's my answer. Okay, this is kind of what we've been practicing, but a little reminder, if the monomials, so this is a monomial, if they have coefficients or numbers in front, like a 7 or a 10 or a 2 or a 4, multiply those, but still add the powers of the variables. So here's what it looks like. Remember, ignore these parentheses. This is question 1, this is question 2. Ignore them. Ignore them. Don't use them. We'll talk about parentheses later if in a different lesson. But for these parentheses are the associative property. You don't need them right now. Here we go. I took the 4 and I'm going to put it with the 2. So 4 multiplied to 2 is 8. Next, I'm going to take the a to the 9th and put it with the other a to the 4th. So how many a's do I have here? 9 a's and 4 a's. Again, if this is difficult, it's okay. What I'll do, I'll recommend that you write them out. If you need to, write out 9 a's and 4 a's and count them up, and you'll get 13. If you do that enough times, eventually you'll go, oh, all we're doing is 9 plus 4. Yeah, that's all you're doing. B to the third and then b to the first. So 3 b's and 1 b give us a total of 4 b's. And I wrote a d, sorry. B to the fourth. Get rid of that. Dyslexia. Okay, there we go. That's it. Final answer. 8a to the 13th multiplied to b to the fourth. One last example. Again, these are multiplying, so it means 7 multiplied to this, multiplied to this, multiplied to this, so ignore the parentheses and rewrite everything with the commutative property. Okay, 7 multiplied to 10. That's 70. Now I have W2, W10. So W to the second multiplied to W to the 10th. That's a total of 12 W's. W to the 12th power. This is Y to the 5th multiplied to Y to the 2nd. So that's a total of Y to the 7th. All I'm doing is adding the exponents. Okay, there's my answer. I'm done. Practice problems. Now, we just finished multiplying powers. This is from the beginning of the video, combined like terms. So you need to slow down because your brain's doing two different things. When you combine like terms, the exponents have to be the same. Oh, careful, careful. Okay, they have to be the same, the exact same. Now this is xy and this is also xy, just mixed around. So those are the same. All right. But when we do the multiplying, they don't have to be the same. So adding or subtracting, they need to be the same in order to put them together. On these practice problems, you're multiplying everything. There is no plus or minus. So then it doesn't matter if they have different exponents. It doesn't matter. Just put your r's together and put your y's together and your x's together and put them all together and add up your exponents. Okay, good luck, and bring any questions you have to class next time we meet. Take care.